Okay, run through a demonstration of how to do server to client connectivity using Zscaler private access and branch connector. So I've got a couple of machines defined here for client to client. So they're defined as remote machines. It could be a wildcard or whatever. Specifically, this one I'm going to use desktop 5UQ7SLP. And I've got a cloud connector, branch connector deployed. Here's my ZPA pool and branch connector. It's going to have logged me out, which is great. Let's fill that record there. So I've got a branch connector deployed, which is capable of intercepting the traffic. And if we come across to my routes, I've got a route for the 172.33/16 network via the branch connector. I've also got a 1.1.1/24 via that, and I will come to that later on when we talk about connector by IP address. So what does this mean? So let's come across to my domain controller, and this tells me that the desktop is 192.168.1.71, and if I connect to that, in fact, what we'll do is we'll come back to that command prompt in a second. We'll ping desktop 5UQ7SLP welshgeek.net, and I get that 172 address. The firewall's blocking ICMP, but that means that if I connect to it, I'm connecting to it directly at the moment. No ZPA or anything involved, directly to that IP address. But this machine is registered. You can see here we're running 4.1 release of Zscaler client connector. The client IP, the hostname validation is identified desktop 5UQ7SLP welshgeek.net and registered that through ZPA. So if I come over here and I dig desktop 5UQ7SLP welshgeek.net at 192.168.1.65, I will get that synthetic IP address back. This is generated by ZPA, by the actual branch connector, and says, okay, this is a host you want to connect to. It's a valid app segment. This is the IP it's going to resolve to, and we route this into the interface of the branch connector, and it'll then pass through branch connector, the service edge, app connector, well, not the app connector, through to the client connector to perform that interception. Now, I could go ahead and update my DNS on my client to point to this. In fact, why don't we go ahead and do that? Wi-Fi settings, network, details, DNS 65. Okay. Okay, so I'm now actually connecting to that IP address, resolving directly to that IP address. So if I come across here, in fact, let's just double check ping desktop 5UQ7SLP welshgeek.net. I'm correctly resolving it, and so if I remote desktop to it now, this should pass through the branch connector. Yeah, took a little second for it to figure things out. So we pass through the branch connector, through ZPA, and end up on the device. And we know this. If we run a netstat -an, find string 3389 str 3389, we can see the connection through to the RDP listener is coming from a loopback address. It's actually coming from the client connector process itself. And if we come across to private access and go to diagnostics, and we seem to have a bit of a delay here. What we'll do is we'll go to live logs, and we will disconnect this session and reconnect it. And we see the connection here is from a client of branch connector. The destination is the desktop. The IP address of the desktop is there, and so we know that it went through essentially client-to-client connectivity. So branch connector kind of functions as a client, essentially gives us client-to-client connectivity through to the device. And we do that by FQDN. Now, what about the scenario where I can't actually reconfigure something to point at the branch connector for DNS? A good example of that is Active Directory. I might not be able to point my Active Directory domain controller at the branch connector for DNS because Active Directory is a DNS server in itself. So I might have challenges for that. Other ones being applications that need to scan a port range or scan all clients by an IP address, and therefore they just won't do a DNS lookup. So in that case, we have the new functionality in the 4.2 release of the client, and so what we'll do is we'll come across over to mobile, and I'm going to roll out a specific version, 4.2073. Click Save and Roll Out. Let's proceed with that. And being that I'm remote desktop onto this machine, I will update the app here. And that should go ahead and update the client. With a bit of luck. Yeah, it's just rolling out the update. It's probably going to have disconnected me in the meantime. Whilst I'm doing that, I will come back across here, change my Wi-Fi settings, network. We'll go back to the DNS server, which is my domain controller. Back at that IP address. This will just give me the connectivity back into the machine to show you what's going on. So let's take a look at Zscaler now. I've still got the registration, desktop 5UQ7SLP, but Zscaler has allocated an IP address, a synthetic IP address of 1.1.1.2. And if we do a ipconfig/all, it doesn't actually appear as a network IP on the machine. It's just something that the Zscaler client connector is aware of. We come across the private access portal, and we go to administration and client IP assignment. I've got some IP ranges. I've said I want to allocate machines that are in London, the 1.1.1.1 to 1.1.1.254 range, and we come across here and we can see the machines have registered. So what does that actually look like? So for the same reason, if I come back over here, I go netstat -rn grep 192.168.1.65. I've got this 1.1.1 range, 1.1.1/24. Next hop is 192.168.1.65, so the branch connector. And so if I come over to my remote desktop, in fact, let's just terminate this one. I can say that I want to connect to 1.1.1.2. Click Save. Remote desktop. Click Continue. And I'm still connected into the same device. Again, that netstat shows that it's still connecting via the loopback address. If we come across to the diagnostics live logs, let's just reconnect that and get the live log in there. Different port, different connection. If we come across here, we can see the logs at this point. And so the distinction here is that it actually sees you connecting to 1.1.1.2, and it's mapping to an application segment 1.1.1.0/24. So I have to define a different segment for those ranges to enable me to connect through ZPA to match those app connectors. The client connectors that it's behaving as the termination point. We still see the IP address here of the real machine. We still see it as branch connector and client-to-client connection type. We come across here to the client connector IP assignment. This should show the client host name in here. And I'm not sure why it suddenly decided not to do that, because this was there a minute ago. Let's try restarting the service and see whether or not we can kick this into suddenly returning the information. Okay, not quite sure why that is. That's going to be some kind of bug to look at. So you can see now it's registered desktop 5UQ7SLP as the device. Now, or back to you might have machines like your domain controllers, your SCCM servers that might also be DNS servers that you cannot point towards the branch connector for their DNS, but they still need to be able to know what to connect to. So you can download as a CSV file. Let's download this file. Let's just open this. So you might want to import the client IP information into whatever management tool that you might need to connect to things by the IP address with. That's one way to do it. The other thing you might look to do is do this programmatically. So what I've got here is a bit of Python and a bit of configuration that enables a process to update DNS. So let's take a look at the run script. The run script, there's a bit of sort of approximation to documentation here. What it's really doing, I've got a key tab file here. This is a Kerberos ticketing key tab. Enables a process to run as a Kerberos with a Kerberos account. So the purpose of this is it's going to connect to the DNS server with that Kerberos ticket and update DNS. What we're going to do is we're going to use this Python. This basically downloads that CSV file and outputs the format ready for updating into DNS. So runs the kInit to get the Kerberos ticket. It runs the Python that downloads the data from the ZPA admin UI. And then it creates a file called update.txt, and it runs the NSUpdate against Active Directory to update these new synthetic IP addresses. So let's run this. We'll cat the update.txt, and you can see what it did. It created the file, and it says, okay, well, I now know about desktop 5UQ7SLP, and I'm going to update it now with the IP address 1.1.1.2. Okay, so if we come across here now to my domain controller, you can see as we started off, it says 71. If we refresh this, it now says 1.1.1.2. And so if I come across to my client machine, and we will run a ds cache flush cache. We will do something kind of interesting. This is where we need to change the time to live. What we will actually do is force the client to refresh its DNS by turning the network adapter on and off. Okay, reconnecting the network adapter causes WinMac to flush its DNS. Could do with a different TTL on the DNS entry. And so this is actually dig at 192.168.1.2 desktop 5UQ7SLP, and it says okay, it's got quite a long TTL for this, so we should change the TTLs. But this is the IP address I now want to connect to, which means that if I come back across to my machine, I connect to this now, connecting to it by FQDN, but now we're connecting to this synthetic IP address. We can run the netstat -an. We can see that it's still that loopback address. And if we come across here, netstat -an, we can see that my client is connecting to the synthetic IP address 1.1.1.2, and we know that netstat -rn 1.1.1 is going via the branch connector, and we come across to our live logs. not sure what's going on there. Disconnect and reconnect to generate the log information. And we see the connection here. So my client machine went through the branch connector to 1.1.2, and at the same time the machine validated my credentials against Active Directory when I connected. So everything is now working with segmentation. I can access remote devices by an IP address and inject that into a DNS system. I hope this is useful. Mark at zscaler.com.